Okay, we're ready to go ahead and start 2.6 radical equations, and it's going to be radical. Okay, two objectives, not a real long, lot of stuff. We'll just look at a lot of examples, but solving radical equations, it's really the main thing, and solving equations with positive rational exponents. If you remember, rational exponents simply means that you're dealing with radicals. And so what we have going on here is we do have rational exponents, but it's the same thing as just saying radical equation. So really the same objective twice. Now, what is a radical equation? Now, it's really any equation, equal sign, where there's a radical, specifically where there's a variable inside the radical. If there's a variable only on the outside, then really what we have is a radical of a number, which is just a value itself. And so what we want to do is we want to convert a radical expression into a polynomial so that we can manipulate it and solve for the unknown. So really, if we have a variable inside of a radical, if you can sort of picture that right here, what we need to do is we need to try to peel off the radical. I mean, that's what we're trying to do, is we're trying to take this radical and peel it off so we can get to the x. So we need to undo radicals. Well, to undo a radical, we need to use inverses. And the inverse of a square root would be a square, and the inverse of a cube root would be a cubed, and so on. So depending on what the index is, that's going to sort of tell us what we're going to do, what we're going to utilize in order to rip off that radical so we can get to the variable. Now, one thing you want to keep a track of is we've talked about this before with other things like absolute values, but there's a possibility of extraneous solutions, which means that you've done everything right, you get an answer, it just doesn't work back when you plug it back in. So you don't have much of a choice here. You have to check your answers just to make sure you don't have an extraneous solution. Okay, now, sort of the methodology of this and how do we go about actually solving radical equations? Well, there's just a few steps here we want to take a look at. Step one, we want to isolate. It's a lot like the absolute value. We want to isolate the absolute value so that we can, so we can set up our two cases. Here, we want to isolate the radical so we can peel off the radical. So really, step one is to pick a radical expression, whatever the radical is, because there may be more than one. And if there is more than one, you can only choose typically one at a time, and you want to get it by itself, nothing else on the other side. So if you had something, let's say, like 2 plus the square root of x equals some number, like 4. We'd have to move that 2 first so we can isolate that radical. Okay. So we want to isolate a radical with the variable inside first, step one. Then what we want to do is we want to undo that radical. We want to peel off the radical. So we're going to use this idea of the inverse root. So if the index is a 4, we need to raise it to the 4th power because the 4th root, the square root, the cube root, they all have inverses, which are exponents, powers. So depending on what the root is, the nth root would be the nth power, no matter what the n is. And we just need to make sure we raise both sides of that. It needs to be both sides. And I really emphasize the word sides because it's not terms. Okay, if one side had an x plus 2, and I want to square both sides, I don't just square the x and square the 2, I'm squaring terms in. I square a quantity. So it ends up being a FOIL of some sort. And so be careful of that. I don't want you to fall in the trap of just squaring or cubing terms. You've got to do that to entire sides. Step 3. Now, step 3 says if any radical expression remains, so let's say there was 2, one on one side, one on the other, and you can only get rid of one at a time typically, unless you get one of those special ones. Then what you got to do is you got to start over. Once you get rid of one, you got to get rid of the other because we got to get all the x's in a point where there's a polynomial so that we can solve using the polynomial methods we're comfortable with. So like factoring or just solving for the specific variable if it's linear or whatever it needs, quadratic formula if it's another type of quadratic. The final step is to check your answers. Remember, there are extraneous solutions out there, so we must plug these back into the original equation to make sure they work. So don't just get going so fast that you get answers and move on. Sometimes they just won't work. So let's actually look at some of this. That's really it. You need to go back and review, go back and re-look at those notes. But if we look at a problem like this, we go, okay, let's just go step by step. Step 1, we need to make sure this radical is isolated. So I'm trying to get this isolated by itself. So this 2 needs to move. So I'm going to move it to the other side with the x. And so what I have is I have the square root of 2 plus x equals x plus 2. Now once I isolate a radical, I want to undo it. I want to get rid of the radical. So I peel it off. And so if I can peel that off by squaring it, it will undo the square root. Whatever I do to one side, I got to do the other side. That's important. It's a side, not terms. And so I've got to end up foiling. Now this side, they cancel, and so you're just left with 2 plus x. On this side, you go ahead and foil, and you end up getting x squared plus 4x plus 4. It's quadratic. There's your x squared. There's your quadratic term. So we need to go ahead and set this quadratic equal to 0 so that we can solve by factoring our quadratic formula. So I'm going to go ahead, move everything to the right side because I like keeping my a positive for quadratics. I'd advise you to do the same. And so we get here, and we get to this point, and whoa, there we go. This one can be factored as x plus 2, x plus 1. And now what we go is the zero factor property. And so what we have is we've got x is -1 and x is -2. Now we got to make sure these work, and so I'm going to plug these back in. If I plug in -1, I get 2 minus 1, which is 1. Square root of 1 is 1. What's 1 minus 2? Well, it's -1. And that's what x is -1. So that works out. Good for it. -2, I plug it in. I end up getting 0. What's the square root of 0? Well, 0. 0 minus 2 should equal -2. Does it? Yes, it does. So we get 2 answers, -1 and -2. And so that worked out really nice. Apparently this is, there we go, -1 and -2. Moving on to the next problem. Here we go. This is one of the more complicated ones because now what we have is we have 2 radicals. Unfortunately, I can't just square everything because you can't take an exponent across the plus or minus sign. And so we can square entire sides, but that doesn't help. If I just square this entire side and I foil, I still am going to have radicals left behind. So let's just go step by step. Don't try to do too many things here. And so the first step we need to do on this type of problem is we can go ahead and isolate one of these 2 radicals. It doesn't matter which one. I'm just going to go ahead and do that one because I just want to. And so I go ahead and I subtract that from both sides. And so what you'll notice is I have this radical by itself and the other radical with the 1 on the other side. Now, okay, here we go. I got to peel off this radical. I know we have one over here, but this is what I'm focused on, is I want to get rid of this one, so I'm going to square that. And that's going to leave me x plus 3. Now, whatever I do to one side, I have to do the other side. Not terms, but the entire side. Okie dokie. So we got some work here to do. So I'm going to have to end up foiling this. So you have to expand it. So this is a binomial expansion. So we got 1 minus the square root of x plus 4. I'm going to go ahead and expand this out. So I end up getting 1 minus 2 square roots of x plus 4. Here's the tricky part. What's a negative times a negative? Positive. Square root of x plus 4 times square root of x plus 4. When square roots, the trick is whenever you multiply something times itself underneath radicals, you should get whatever the radicand is, which is x plus 4. Okay. Now what gets really tricky is if for some reason that ends up being a minus sign. It won't when you have something like this, but you make sure to distribute through that x plus 4. Anyways, let's move on. Now what we have is we have to get this one by itself. It's repeating. It's a looping around. We did steps 1 and 2. Step 3 says if you still have one, repeat steps 1 and 2. So I need to move all these things over here to the left side. Okay, so I've got to subtract x. Well, goodbye x. Okay, I got to subtract 4. Okay, and I go, oh, that's -1. I got to subtract another one. So I end up getting -2 equals -2 square roots of x plus 4. I still don't have that radical by itself because that multiplication of -2 is in the way. So I go ahead and divide both sides by -2. And there we go. We get something that's very much manageable. And so I go, well, I got to get to the x. Remember, that's my goal. So I got to peel off the square root. How do I undo a square root? Well, I square it. Whatever you do to one side, you got to do the other. And so now what we have is we get our final answer of -3. And we go, does it work when I plug it in? Well, if you plug it in, you end up getting 0 here. And you get 1 there. What's 0 plus 1? 1. And so just to double check it, our answer is -3. Make sure to check your answers for those extraneous ones. Let's take a look at this one. Notice the index is a 4. Really not much different of a problem than what we did, just that the index is different here. First things first, I've got to go ahead and isolate the radical. And so this radical needs to be by itself. Okay? And then so I got to add this 1 to both sides. So there we go. Now how do we undo a 4th root? Hopefully you're saying you'd raise it to the 4th power. Those would be inverse operations of each other. So to peel off this radical, I've got to go ahead and raise it to the 4th power. And so this is going to cancel. And I end up getting, oh, look at that. I got a quadratic. Okay, what do we always set quadratics equal to? 0. And so I got to go ahead and subtract the 1 from both sides. And now we can look to factor, and yay, we can. That works out pretty nicely. And now zero factor property, you end up getting 2, and you end up, ran out of ink there, okay? And end up getting 2, and end up getting -1 as your 2 solutions. Now they both have to work. So let's plug in 2. I get 2 squared is 4. 4 minus 2 is 2. 2 minus 1 is 1. What's the fourth root of 1? Well, it should be 1, right? What's 1 minus 1? 0. Yay, yay for 2. Okay, negative 1. Negative 1 squared is 1. Then we get plus 1, then we get minus 1. So we end up getting 1. What's the fourth root of 1? 1. What's 1 minus 1? 0. So that one works as well. So we haven't seen an extraneous one yet, but time will come when we get one. That was 2 and negative 1. Always keep checking them, though. Always keep checking them. Even if you don't get extraneous, they're out there. Let's look at another one. This one right here. And so, again, we start off with going, well, I got to get the radical by itself. Okay? And again, this would be a good time to pause and you work through it and then jump back in and watch me. You can do that on those other problems as well. So anytime, just pause, work it out, see if you get the same answers as I do. I need to go ahead and add 1 to both sides. Now I got to undo, I got to peel off that square root, so that means I'm going to square both sides. And that undoes the square root, and so I get 1 minus x. Oh, I got to expand this. Can't take an exponent across a plus or minus sign. We have to make sure to binomial expansion, we FOIL it out. And look at what we got again. We got another quadratic. So what do we set quadratics equal to? 0. And so we go ahead and we add x to this side and we subtract 1. And so we end up getting 0 equals x squared plus 3x, and the 1's cancel. Well, this is an easy one to factor. If you can see it, there's a GCF, and we always look for a GCF when we factor first. So we go ahead and we get that. And zero factor property, you set them both equal to 0. And what you end up getting is 0 and negative 3. And you're like, yes, 0 and negative 3. Let's plug them in. So I plug in 0. I get the square root of 1, which is 1. Okay, remember, x is 0, right? So what I get is I get square root of 1 is 1. 1 minus 1, does it equal 0? Yes, it does. That's a true statement, so that one works. If I do negative 3, I end up getting 1 plus 3, which is 4, right? What's the square root of 4? 2. So I have 2 minus 1, and it should equal negative 3. Uh-oh. There you go. That's the one. Okay. Unfortunately, negative 3 does not work when I plug it back in. It doesn't give me a true statement, even though we didn't do anything wrong. It just doesn't work. All I get is just the answer of 0. And so if you take a look here, we do get 0, negative 3. But negative 3 doesn't work. 0 is your only answer. So if you got that working by yourself, you're ready to roll. You're doing a great job. Okay, now let's go ahead and again, this just says be cautious of the extraneous solutions to check them. That's the one that we just finished up. But let's go ahead and take a look at rational exponents. Now, with rational exponents, we're talking about radicals. There's not a difference. All it is another way of writing the same thing. So a real quick review, square root is the same thing, like the square root of x is the same thing as x to the 1/2. The index goes on the bottom. The power of either the radical or the variable goes on top. So let's say we had like the cube root of x squared. What that would be x to the 2/3. The index goes on bottom. The power goes on top. Now this would be the same thing as putting the exponent outside the radical as well. So just a little review. You might jump back to chapter 1 if you need to spend more time on those rational expressions. But we're going to be moving on here for today's lesson. Now what we want to do is simply rewrite. Okay, and I think it's because most students are very comfortable with radicals. We get used to them. We know how to undo them. We see square roots. We know squares. With exponents, sometimes when they're rational, we have a little bit harder time. You don't have to rewrite. I just encourage you to do that. I think that's going to be the best way for you. So let's see this in action. So you have x to the 2/3 minus 16 equals 0. Well, first things first. Let's just rewrite this. Don't even start with any process or anything else. My index is a 3. And then my x is x squared. So it'll look something like this. And then minus 16 equals 0. I think at that point, now you're ready to solve. And it's no different than what we did prior to this problem. What you want to do is isolate the radical. So this needs to be by itself. So add your 16. Okay. And again, always utilize the pause buttons and rewinds before I finish up. Go back and try this before I even start. Write it down, see what you can do. That's the beauty of a video, is you can pause, you can rewind, you can fast forward, and you can watch it multiple times. So take advantage of those opportunities. At this point, we want to peel off the cube root. Okay, well, what's the inverse? How do I undo a cube root? Well, wouldn't I cube it? Okay, and so whatever you do to one side, you got to do the other, and we end up cubing 16. Now, there's a few things you can do here that could have made your life a little easier. You could have put the square on the outside and square rooted both sides and then cubed it. It would have been a smaller number, so it would look something like this. I think I'm going to do it because I don't have a calculator handy on me. And so you could have written that same thing that we have here, just like this. And then that would equal 16. So how do I undo a square? Well, you can square root both sides, but don't forget the plus or minus signs. So I'm going to cube 4 and I'm going to cube negative 4. And so what I end up getting is I end up getting 4 times 4 times 4, which is 64. Or when you do negatives, it would be a negative 64. Now, let's see if we get the same thing here. The cubes are going to undo each other. And then 16 cubes is going to be 16 times 16 times 16. Now, if you are going to multiply those three, grab a calculator. So here we go. So 16 times 16 times 16. It'd be a lot easier than me trying to do it in my head. You get 4096. Then you square root 4096. And what you end up getting is you get 64. But don't forget, you're personally responsible for that square root sign. So that means you must have the plus or minus sign in front. And look at our answers. Isn't that amazing? That's so cool. You end up getting the same thing. Positive 64, negative 64. We do need to make sure they work though. So we plug it back in. Now this is where students are like, I don't want to do this. But you need to. You never know. And so we go ahead and just do the cube root of 64 first. Cube root of 64 is 4. What's 4 squared? Well, it's 16. What's 16 minus 16? 0. So it works. So definitely 64 works. If we do negative 64 to the 2/3, okay, minus 16 equals 0. Let's see if this is also true. What's the cube root of negative 64? Negative 4. What is negative 4 squared? Well, negative 4 squared is 16. What's 16 minus 16? It's also 0. So what you'll notice is 64 and negative 64 both work. Those are your two answers. Two different ways of doing it, though, and that's what the cool thing is. Most of the time, we're going to probably end up utilizing this way of doing it. But because the number 16 cubed was so huge and I didn't have a calculator on hand, this would have been appropriate as well. I can still do it. But with a calculator, no problem. Okay. All right, look at one last one before we're done with this one. And so we're sort of step by step on this one. Again, just pause it if you want to work all the way through it and see what you get. And you'll notice it's going to be a quadratic, I hope. And then restart it and see if you get the same answers that I do as I walk through it. So no writing. This one's actually typed up, so it'll look pretty. So first thing we got to do is we've got to go ahead and raise both sides to the fourth power, because really we rewrite this as the fourth root of all that. And so it's the fourth root of that whole polynomial. Okay, the radical is already isolated, so all I got to do is peel off the fourth root. How do I undo a fourth root? We'll raise both sides to the fourth power. What is 4 to the fourth? Well, 4 to the fourth, is we're going to find out real quick, is 16 times 16, which is 256. And so 4 to the fourth, 256. Now notice what we have. We have a quadratic. There's your x squared. What do we always set quadratics equal to? 0. So we need to go ahead and subtract 256 from 130. So what you end up getting is 7x squared minus 21x minus 126. Now, this one could be factored potentially. I think it does. So you can use the quadratic formula as well. This one's a large one to factor, but the safe thing here, and I know it's hard for you to see, but I believe 7 goes into all three of those numbers. So if you take 126 and divide it by 7, you actually get 18. And so if you notice that, it's tough to notice, but I can divide everything by 7. And in doing so, I end up getting that x squared minus 3x minus 18 equals 0. Man, is that so much easier to factor at that point. So you can factor out a 7, or like what I did is divide everything by a 7. It doesn't matter either way, because that 7 is not going to play a role in the equation necessarily. So this one you can go ahead, and it's a trinomial, so factors that add multiply to be negative 18, half to negative 3. And so what we end up getting on that is we end up getting x minus 6x plus 3. And then you use the zero factor property, set both those bubbles equal to 0, and you get 6 and negative 3. And then just make sure they work. And in this case, both answers do work when you plug it back in. That's where a calculator will come in handy, plugging both these back up in here into the original. Even the second one would be appropriate for you to plug it back into. Okay? And that's radical equations. That's really it. Best of luck to you.